Stereolithography is an additive manufacturing or 3D printing technology used for producing models, prototypes, patterns, and production parts up one layer at a time by curing a photoreactive resin with a UV laser or another similar power source. History: the term stereolithographer or Euro was coined in 1986 by Charles W. Hull, who patented it as a method and apparatus for making solid objects by successively printing thin layers of an ultraviolet curable material one on top of the other. Hull's patent described a concentrated beam of ultraviolet light focused onto the surface of a vat filled with liquid photopolymer. The light beam draws the object onto the surface of the liquid layer by layer, and using polymerization or cross-linking to create a solid, a complex process which requires automation. In 1986, Hull founded the first company to generalize and commercialize this procedure, 3D Systems Incorporated, which is currently based in Rock Hill, SC. More recently, attempts have been made to construct mathematical models of the stereolithography process and design algorithms to determine whether a proposed object may be constructed by the process. Technology: stereolithography is an additive manufacturing process which employs a vat of liquid ultraviolet curable photopolymer resin, and an ultraviolet laser to build parts layers one at a time. For each layer, the laser beam traces a cross-section of the part pattern on the surface of the liquid resin. Exposure to the ultraviolet laser light cures and solidifies the pattern traced on the resin and joins it to the layer below. After the pattern has been traced, the SLA's elevator platform descends by a distance equal to the thickness of a single layer, typically 0.05 ohm to 0.15 ohm. Then, a resin-filled blade sweeps across the cross-section of the part, recoating it with fresh material. On this new liquid surface, the subsequent layer pattern is traced, joining the previous layer. A complete 3D part is formed by this process. After being built, parts are immersed in a chemical bath in order to be cleaned of excess resin and are subsequently cured in an ultraviolet oven. Stereolithography requires the use of supporting structures which serve to attach the part to the elevator platform, prevent deflection due to gravity and hold the cross-sections in place so that they resist lateral pressure from the recoater blade. Supports are generated automatically during the preparation of 3D computer-aided design models for use on the stereolithography machine, although they may be manipulated manually. Supports must be removed from the finished product manually, unlike in other, less costly, rapid prototyping technologies. Advantages and disadvantages: one of the advantages of stereolithography is its speed. Functional parts can be manufactured within a day. The length of time it takes to produce one particular part depends on the size and complexity of the project and can last from a few hours to more than a day. Most stereolithography machines can produce parts with a maximum size of approximately 50A, 60 cm, and some, such as the Mammoth stereolithography machine, are capable of producing single parts of more than 2 meters in length. Prototypes made by stereolithography are strong enough to be machined and can be used as master patterns for injection molding, thermoforming, blow molding, and various metal casting processes. Although stereolithography can produce a wide variety of shapes, it has often been expensive. The cost of photocurable resin has long ranged from $80 to $210 per liter, and the cost of stereolithography machines has ranged from $100,000 to more than $500,000. Recently, renewed public interest in stereolithography has inspired the design of several consumer model printers with drastically reduced prices, such as the Ilios HD by OSRC, the Form 1 by Formlabs, the Titan 1 by Gudo 3D, the Pegasus Touch by FSL 3D, and the Nobel 1.0 by Shies Printing. There has also been a drastic reduction in the cost of photocurable resins, with USA-based providers such as MakerJuice Labs offering materials as low as $40 per liter and European-based providers such as Spot A Materials offering materials for a $68 per liter. See also, stereolithography, references. Notes. External links: Ilios Modular 3D Printer by OSRC with industrial-grade motion, fully metallic construction and highly accurate repeatability rates, Super precise Kudo 3D Titan 1 SLA 3D printer hits Kickstarter on May 27 starting at $1,899. Pegasus Touch by FSL 3D Laser SLA 3D printer, low cost, high quality on Kickstarter. Formlabs Form 1, a low-cost stereolithography printer being designed and fabricated as a Kickstarter project. How stereolithography works from howstuffworks.com. Rapid prototyping and stereolithography animation. A Euro animation demonstrates stereolithography and the actions of an SL machine. Video of microstereolithography for biomedical applications.